Now we will be describing the changes to be made in the project files through which a formation control can be achieved. And as an example, we are showing for 3 MIP agents, MIP1, MIP2 and MIP3. So the project structure as described before still remains the same. So there are a few changes in each one of these projects. So one of the changes is in the UART interrupt. Now, apart from transmitting the x, y and theta position, hence 3 variables, each agent also receives the states of the other agents. So hence there is a receive code which has been coded now. So the transmissions occur in the following way. First, each agent transmits its agent number. Hence, each agent is looking out in the data stream for the neighbor agent numbers. So since this is agent number 1, agent 1 is looking for in the data stream in a synchronized way the number 2 and number 3. Now once the agent flag is encountered, so we increment the count of the received data to 1 and we make the start count 0, and once the next data is encountered, it is entered into the corresponding array. So this is a 2-dimensional array where since 3 data is received from each agent, which is 3 integers, so there are 6 data elements, totally 6 bytes to be received, and with n number of agents, and the receive register data goes into the corresponding location in the array and the count is incremented. So once the count becomes 7, which means the flag is received and all 6 bytes are received, which means the flag becomes 7, count becomes 7. So now the once if all 3 agent data are received, there is a flag called flag once which is set to 1. So this is a one-time phenomenon which happens at the beginning of the total interaction process. So let's assume it is already 1. So since this, once it receives the last agent's data, which means since this is agent 1, if it receives the last agent's data, which is agent n, which is represented by agent TOT, total number of agents, it will calculate the average of the neighbors, or depending on the control strategy, whatever the desired control code has to be, control code or the data interpretation code has to be inserted here. In this particular control law, the average of the neighbors is calculated. First, the total x average and y average is the x and y data is rebuilt from the bytes received. So the upper byte is left shifted and then the lower byte is added. So that is the code shown here, and then the x and y average is calculated with the offset hx and hy, which represents the offset from the centroid for each agent, and then the process keeps continuing. So once the agent 2 and agent 3 data is received, agent 1 transmits its agent number. So this is the reason why we keep track of which agent is transmitting the data. And this transmission protocol is now like a round robin fashion. So after agent 1 transmits, agent 2 will transmit, then 3, then again 1, then 2 and 3. So as described earlier in the code flow and the code description, since the transmission is set off automatically through your transmit interrupts, the rest of the data will be transmitted. And since this is the agent 1, it has a little excess code to take care of transmission failures from agent 2 and agent 3. So there are counts which keep incrementing in the IMU interrupt, and if the count exceeds a particular value, which is as of here it's a representative of 0.1 seconds. So if for 0.1 seconds agent 2 and agent 3 data are not received, so it will start off the transmission again. So to avoid total communication failure, so the round robin communication will be again initiated by agent 1. So this is the only additional change in agent 1 in the IMU interrupt code. So the other changes will be in the variables. So in the variables there are arrays created, the current agent's number is stored, the total number of agents are specified, and the offset from the centroid is specified. So the same changes are there in all 3 agents, agent 1, agent 2 and agent 3. But a small difference would be, so in agent 2 it will be looking for agent 1 and agent 3's flag, and similarly in agent 3 it will be looking for agent 1 and agent 2's flag. So the rest of the code remains the same. So each agent will transmit its own agent number after it has received the previous agent's data, and the one's flag for just for a synchronization of all data in the beginning of the experiment also exists in all 3 codes. And similar to the position stabilization code, this project can be opened and then it is built. So the build succeed and other details like code length, memory occupied can be seen. Care has to be taken to load agent 1's project into agent 1 and agent 2 into 2 and so on, because the inertial measurement unit of each robot is different and it has a different value of offset of the sensors like gyro, and the center of gravity of each agent is at a different location, hence a different value of pitch offset has to be added to each agent. So hence care has to be taken to not to recreate files just by copying from agent 1. Similarly, each project can be opened, can be built, and we will later demonstrate the programming into the each agent using the pick kit 3. So each program has to be built separately and loaded out to the corresponding robot. So this is the description of the project structure for the 3 agent average consensus control law.